So we got one more IB question here. Man, what is it with these IB questions? Is they just keep coming and coming. It's like a never-ending stream of joy and happiness. All right, so let's go. First, we're going to sketch the graphs of y equals sine x and y equals sine of 2x on the same set of axes for 0 to pi over 2. Now, hopefully you know what sine looks like. Sine goes like this. And it goes from 0, pi over 2, pi, 3 pi over 2, 2 pi. So really, we're just looking at this first section here. And if you need to draw that over on the side, that's fine. But when you draw your graph, it needs to go from 0 to pi over 2. And so sine is just going to go from the middle up to its maximum. So it's just going to go just like that. So that one is sine of x. Okay? Now sine of 2x, you're doubling the x value. So you've got 2 times x. Transformations remind us that that means that the horizontal is going to do the opposite. So instead of being double, it's going to be half. So you're going to get twice as much in. So you're going to get in that whole first hump because that would have gone to pi. And so it's going to go something like this up in the middle. And if you want, you can actually make that mark that that's pi over 4, right? Because it's right in the middle. But that's our sine of 2x, and that's in the right region. So next, what we want to do is find the x-coordinates of the points of intersection of the graphs. All right, so in order to do that, we're just going to do some straight up math. Obviously, we've got 0, so x equals 0, no problem. And then to find the intersection, we just have to set them equal to each other. So we go sine of x equals sine of 2x. And hopefully you know the double angle formula for sine of 2x, which is 2 times sine of x times cosine of x. And if you don't know that, you should recognize that double angle formulas are wacky, and so we want to get rid of it. And then you go look in your formula booklet and you go, oh, there's the double angle formula. And then you can put it down. And so, of course, once we have this, we want to move things over. It doesn't really matter which one you move where. I like having the bigger one to be positive, so I'm going to subtract the sine x. So I'm going to have 0 equals 2 sine of x cosine of x. See, at this point, you guys don't freak out when 0 is on the left-hand side. That's an issue in Algebra 1, but not necessarily for you guys. So then we have 0 equals sine of x times 2 cosine of x minus 1. So obviously, sine of x equals 0 at your origin there. That's the one that we got. So now I just need to do 2 cosine of x minus 1 equals 0. So I add the 1. I get 2 cosine of x equals 1. Cosine of x equals 1/2. And if I think about my trig and do all that fun stuff, cosine is adjacent over hypotenuse. So I got my adjacent is 1, my hypotenuse is 2, and what kind of triangle has that? Well, of course, it's 4 pi over 3. And so 0 and pi over 3 are my two answers, and I'm doing all right. We're just cruising right along. So now I need to find the area enclosed by the graphs. So now that I know I'm looking for the area enclosed by the graphs, we're going to go bloop, bloop, and we're going to just zoom out just a little bit. So to get the area enclosed by the graph, I'm just simply doing the integral from 0 to pi over 3 because those were the intersections. And then which one is on top? Well, the sine of 2x is on top. So we're going to do the integral of sine of 2x minus the sine of x dx. All right, and from this point, you can just straight up take the integral. And so we do know that the integral of sine is cosine. No, you're right, it's not cosine, it's negative cosine. Good, just checking to make sure that you're paying attention. So I've got negative. Now remember, this has a argument that has a positive 2. So that's our a, so we got to put 1 over a in the front. So 1/2 cosine of 2x. And then we just have a simple minus, but because it's going to be a negative cosine, we'll make it plus cosine of x from 0 to pi over 3. All right, so from here we can just put them in. And so I go negative 1/2 cosine of 2 times pi over 3. So 2 times pi over 3, you could just kind of think about what you got over here. You got pi over 3, and then you got 2 pi over 3, which is exactly the same on the other side. So cosine of no, let's just go ahead and put it in for now. 2 pi over 3 plus cosine of pi over 3 and then we go minus, and we put the zeros in, and of course cosine of 0 is 1, so this is just going to be negative 1/2 plus 1. Alright, and then we continue to work it out from there, and we end up negative 1/2 cosine of 2/3 should end up giving us negative 1/2 times, and then cosine of 2/3 is negative 1/2, and then plus cosine of pi over 3, which is again 1/2. We already knew what cosine of pi over 3 was because we did it over here. And then we got plus 1/2 and minus 1, and we put all those together, and we've got 1/4. All that cancels out, and so we're left with our answer of 1/4. That's not so bad, is it? Is it? Alright, here we go. Let's go on with letter B. We're going to zoom back in just for a moment. Find the value of the integral from 0 to 1 of the square root of x over 4 minus x dx using the substitution x equals 4 sine squared of theta. What does that have to do with the stuff up above? Nothing! I think they're just kind of throwing a bunch of stuff at us. So we're just going to scroll down a little bit so we got a little more space, and we'll probably be able to fit it on here. It is an 8-point question. That's going to be a lot of work. You know how substitutions work, but I'm telling you, they're trying to be nice to you. They're just telling you to use the substitution right there. So here we go. We're going to do the integral, and we've got the square root of, now x is going to be 4 sine squared of theta over 4 minus 4 sine squared of theta, just like that. And we do need to find out what dx is, so we're going to go dx equals, and so that's just going to be, we bring the 2 in front, so that will be 8, and then it will be sine of theta, which then has to be multiplied by the derivative of the inside, which is cosine of theta. Alright, just like that. So then we have 8 sine of theta, cosine of theta, just like that. Alright, so now let's do some work. Now notice I just left these off. If you want, you can go ahead and figure out what happens when you make x1 and x0. On this type of question, I usually just like to just leave it the way it is. I'm not going to worry about the restraints too much, because in the end I'm going to go ahead and put x back in. It's completely up to you. You can solve for theta, and you can figure out what should go here for 0 and 1 instead, but I'd prefer not to mess with that. So here we go. Let's see what we can do. Integral. Now of course the top stuff, that's already pretty nice. 4 sine squared of theta, I can square root that. That's 2 sine of theta. And of course I got the 4 on the bottom, so I factor out the 4, which then I can square root. So that's 2, and then I'm left with on the bottom the square root of 1 minus sine squared of theta. And you should know that 1 minus sine squared of theta is just cosine squared of theta. Cosine squared of theta. And so we still do have all this 8 blah on the outside. I did forget the d theta there. Sorry, d theta. So 8 blah d theta. We'll worry about that later. And we'll go ahead and work it out. And so now we'll go ahead and cancel out the 2's. Why not? Because I can. So I've got sine of theta over cosine of theta, because I'm taking the square root of that cosine squared. And then I've got 8. The blah, remember, was sine of theta, cosine of theta, d theta. And look at that. I'm telling you, these guys are so nice to us. The cosines cancel out. So we're going to be left just with the simple integral of sine squared of theta d theta. And from there, we're just going to remember that sine squared of theta is tough to take the integral of, and so we're going to think back to trig where cosine of 2 theta is equal to 1 minus 2 sine squared of theta. And you actually don't have to have that memorized, because that's going to be on your IB formula sheet. And so in this case, we can rearrange it. We add the 1, we divide by negative 2, subtract the 1. So we're going to end up with 1/2. When I divide by negative 2, that's going to be a negative 1/2 cosine of 2 theta. And so I can just put that in for sine squared. So I put that in. And so now my integral is simply, integral of 1/2 minus 1/2 cosine of 2 theta d theta. And I can take the integral of 1/2 because that's just going to be 1/2 theta. And then I can go minus 1/2, and I can take the integral of cosine of 2 theta because the integral of cosine is just sine, and then multiplied by 1 over a because it is a linear argument. And then I'm going to have to worry about that. But what I'm going to do is I'm going to go ahead, and if we solve for theta up here, so I'm just going to take this and I'm going to rewrite it. We're going to solve. I guess we have to solve for theta anyway, so we can put the x back in. So I'm going to divide by 4, so I'm going to have x over 4 equals sine squared of theta. And then I'm going to square root both sides, so it's going to be the square root of x over 2 equals sine of theta. And so arc sine of square root of x over 2 is equal to theta. And so at this point I can go ahead, and if I put that back in, then I end up with 1/2 arc sine of the square root of x over 2 minus 1/4 of sine times 2 times the arc sine of the square root of x over 2. And that is all going to be evaluated from 0 to 1. Alright. Now, if you want, you could just take the double angle formula here. You could turn it back into a squared. It doesn't. You can do whatever you want with it. But at this point, you should be able to put in your 0 and your 1 and kind of, finish things off. So I'm going to just zoom out just a little bit. And I'm going to recopy that down so that we can see it a little better. So there we go. And we're going to put the numbers in now. So I'm going to go 1/2. Now the arc sine, I'm going to put 1 in, so that'll be 1 over 2. So the arc sine of 1/2, so opposite over hypotenuse, which is going to give me pi over 3 there. So 1/2 of pi over 3 minus, now let's see what happens. When I put a 1 into here, I'm going to have the arc sine of 1/2 again. So, oh, sorry, that is not pi over 3. That is pi over 6. I just lied to you. So pi over 6. So arc sine of 1/2 again will be pi over 6. 2 times pi over 6 is pi over 3. So what I want is the sine of pi over 3. And so the sine of pi over 3 is just square root of 3 over 2. So it's going to be 1/4 times the square root of 3 over 2. Because first I found the angle, I doubled it, and then I did the sine of it. And so that all is with the 1, and then I'm going to subtract with the zeros. Now the zeros are going to be a little bit easier because it's going to be 1/2 times, 0 over 2 is 0, and the arc sine of 0 is 0, and then I'm going to go minus 1/4, and again, arc sine of 0 is 0, 2 times 0 is 0, the sine of 0 is 0. It's nice and easy because it's sine. If it was cosine, remember cosine of 0 is 1, and so we'd actually have to write down some numbers here. But this one's just going to be 0, 0, 0, and they're going to go away. And then our final answer right here is going to be pi over 3 minus root 3 over 8. And I did leave off my 8 here, so it should have actually been an 8 in front all along. 8, 8, 8, 8, 8. Man, I really got to work that out. I got to think ahead. So I got all those 8s, and so the answer is going to be 8 pi over 3 minus root 3. Well, it would be anyway if I knew how to multiply. 2 over 6 is 12. And 8 over 12, of course, is going to give me 2 over 3. Man, I'm such a dork. Anyway, some of you are thinking, yes, Mr. Bauer, you are a dork. Okay, very well. Such is life. Okay, so then it says, hence, find the value of the integral from 0 to 2 of arc sine of x over 4 dx. Actually, I completely skipped it because I need that whole thing. So what we're going to do is we're just going to do a quick copy and paste, and we're going to paste it over to a blank page. We're going to finish it off. So let's just zoom back in, zoom, and we're going to go copy, and then we'll go over here and we'll finish off this question. Here we go. So there we go. That's pretty big, and you know what? I'm okay with that. Alright, so here we go. The increasing function f satisfies f of 0 and f of a equals b, where a is bigger than 0 and b is bigger than 0. By reference to a sketch, show that integral from 0 to a of f of x dx equals ab minus the integral from 0 to b of the inverse of x dx. Alright, so let's go ahead and draw a sketch. Okay, so I got a and b. So a is an x value, so a is going to be right here. B is a y value, so b is going to be right there. I have no idea what this looks like, but it's increasing, so we'll just kind of go like this. Alright, so, and most of you guys actually, this isn't so bad. So the integral from 0 to a, so that's this area right here. That's the integral of f of x from 0 to a. So that's the black. Okay, equals a times b, so that's the rectangle. Okay, so there we go. So this is AB. And so I need to subtract off. Well, what do I need to subtract off? Well, what I need to subtract off is here on the y, right? I need to subtract off dealing with the y's, and so let's go ahead and deal with that. So what I want is to be able to subtract off this section right here. So if we think of that, if we get the inverse here and we go from 0 to b, and then we're going to do it of that function, then that's exactly what it is. This right here is going to be minus that area, and that blue area is the integral from 0 to b of f inverse. Now, originally we think of this as being, okay, well, that's of the y dy, but it's important to recognize that when we do the inverse, we're going to actually switch the x and the y, and so since it's now the f inverse, then it's actually going to be x here, and so we make our final switch and just say that that is x dx. Alright, and we've now shown essentially by using the sketch that that is true. Alright, so now that we've got this set up so that we know this is true, so integral from 0 to a of f of x dx equals ab minus the integral from 0 to b of f inverse of x dx. Then what we're going to do is we're going to go ahead and just put everything in so that we can do II, which is find the value from 0 to 2. So a is going to be 2. So it just goes integral from 0 to 2 of arc sine of x over 4 dx. So that will be equal to, a is 2. Now b, remember the original statement says that f of a equals b. So to get b, what we're going to do is put a into this function. So we're just going to go arc sine of a was 2, so 2 over 4. So that's the inverse sine of 1/2, and we've done that one a couple of times in this problem. The arc sine of 1/2, hopefully you remember we did it over here, was pi over 6. And so we got pi over 6. Alright, and so now we've got b, which is pi over 6, so we'll go b 2 times pi over 6 minus the integral from 0 to pi over 6 of f inverse. So what we're going to have to do is find the inverse. So if y equals arc sine of x over 4, then I'm going to do sine first. So sine of y equals sine of x over 4. Sorry, the sign cancels that out. Then we multiply both sides, so 4 sine of y equals x. And switch them, switch the x and y, so y equals 4 sine of x. So 4 sine of x dx. And then from there we can go ahead and just do our integral. So we go equals 2 pi over 6, which is pi over 3. The integral of sine, of course, is negative cosine. So then it can just turn into plus 4 cosine of x integrated from 0 to pi over 6. And if I put 0 in for x, then I get cosine of 0, which is 1. So we'll go ahead and we'll go pi over 3 plus, I guess I should put the pi over 6 in first. And if it's pi over 6, then that's 1 to root 3, so root 3 over 2. So 4 times root 3 over 2 minus, and then 4 times, as I mentioned before, put the 0 and you get 1, so minus 4. And so that's really all that we've got. You can simplify a little bit, I guess. Pi over 3 plus 2 root 3 minus 4, and I believe that is then a totally acceptable answer to the question. So there you go. We've answered that long, stinking long question, but covered a lot of good stuff in there. All right? Good luck.